Formula for Fourier series. Consider real valued function f of x which obeys the following condition called Dirichlet's conditions. So what these conditions are, we'll see now. F of x is defined in an interval, that is c comma c plus 2l, and f of x plus 2l is equal to f of x, so that f of x is a periodic function of period 2l. So this is the first condition I can say. So f of x is defined in an interval c to c plus 2l, and f of x plus 2l is equal to f of x, so that f of x is a periodic function of period 2l. Now second condition, the second condition is f of x is continuous or has only a finite number of discontinuous function discontinuities in the interval c comma c plus 2l. And third case, f of x has no or only a finite number of maximum or minimum in the interval c to c plus 2l. Now we'll see. Also let a naught is equal to 1 upon L integration c to c plus 2l f of x dx. Result number 1, an is equal to 1 upon L integration c to c plus 2l f of x into cos of n pi upon L into x dx. Result number 2, bn is equal to 1 upon L integration c to c plus 2l f of x into sine of n pi upon L into x dx. Result number 3. So these are going to called as a trigonometric series, or I can say that then the infinite series is, so which one already we have seen in the slide, as a naught by 2 plus summation n from 1 to infinity a n cos of n pi l upon l into x plus summation n from 1 to infinity bn into sine of n pi upon l into x. So this is I called result number 4, and this is called a Fourier series. Is called Fourier series of the function f of x in the interval c to c plus 2l, and here this a naught, a n, b n all are called, and also the real numbers, that is a naught, a n, b n. So here this n will take 1 2 3, so I will write in a bracket, n will take the value of here 1 2 3 so on. So this n will take 1 2 3 so on. I can say that, so this a naught, a n, b n, so a 1 2 3, a 1, a 2, a 3, a 4 so on, b 1, b 2, b 3 so on. These all are called the Fourier coefficients. Are called Fourier coefficients of the function f of x, and the result number 1, that is a naught result number, second result, that is a n, and result number 3 bn. So result 1 2 3, all three are going to called as Euler's formula. The formula 1 2 3 are called Euler's formula. So then we can say that it can be proved that the sum of the series of 4 is f of x. If f of x is continuous at x, thus we have, so I can say that the sum of the series 4. What is 4? Result number 4. So this is result number 4. A naught by 2 plus summation n from 1 to infinity a n cos n pi upon l into x plus summation n from 1 to infinity bn into sine of n pi l into x. This is the result number 4. The sum of the series of 4 is function f of x if f of x is continuous. This is very important. If f of x is continuous at x, therefore I can say that the function f of x is nothing but a naught upon 2 plus summation n from 1 to infinity a n into cos of n pi upon l into x plus summation n from 1 to infinity bn into sine of n pi upon l into x. So this is a Fourier series of the function f of x if the function f of x is continuous. So you need to remember what is f of x of the Fourier series, and it is a naught by 2 is equal plus summation n from 1 to infinity a n cos of n pi l up into x plus summation n from 1 to infinity b n into sine of n pi upon l into x, where remember where a naught is nothing but, remember this, a naught is nothing but 1 upon l integration c to c plus 2l f of x dx. Then a n is nothing but 1 upon l integration c to c plus 2l f of x into cos of n pi l into x dx, and bn is nothing but 1 upon l integration c to c plus 2l f of x into sine of n pi upon l into x dx. So these are the nothing but the Fourier coefficients, and also we called Euler's formula. Now we'll see the conditions here. Now the particular cases. So what are the cases? We'll see here. Case number 1. Suppose c is equal to 0. So where we need to apply here? This c is equal to, I have taken this. So if these are the formulas here, if I say that if c is 0 in this result number 1, 2, 3, if you put c is equal to 0, what happens? 0 to 0 plus 2l, that will become 0 to 2l. It will become 0 to 2l, 0 to 2l. So the result number 1, 2, 3, listen here. So suppose c is 0, then f of x defined over the interval, instead of c to c plus 2l, it will become 0 to 2l, and the formula 1, 2, 3 reduces to what here? A naught is equal to 1 upon l integration 0 to 2l f of x dx. Okay, then this is the first formula, reduces here. Then second formula will be, that is a n formula, 1 upon l integration 0 to 2l f of x cos of n pi upon l into x dx. This is a n, this is a n, and bn will be, bn is equal to 1 upon l integration 0 to 2l f of x into sine of n pi l into x dx. So but the Fourier series will remain as what here, the same thing. Then f of x is equal to a naught by 2 summation n from 1 to infinity a n cos of n pi upon l into x plus summation n from 1 to infinity bn into sine of n pi upon l into x. But condition is what here? When c is 0, so this all formulas are going to be happen here, a naught, an, bn, when c is 0. Then when c is not 0, so other value, what is that other value? We'll see now here. So here we have taken c is equal to 0, so we got this result. In this, if we take, so this is if L will be changes to what here, pi. So what happens, we'll see. So listen here. So in case 1, what here I had taken c is equal to 0, then we got these expressions 1 2 3 will changes to what here, 0 to 2l, remaining all will same. But in this expression, if I take L is equal to pi, so what happens here, the expression, so L is equal to pi, then f of x defined as what here, in the interval 0 to, instead of L I will take what here, pi. So 0 to 2 pi, and again these formula will be reduces to what here, a naught is equal to 1 upon pi, 0 to 2 pi, and remaining will be same, and 1 upon pi, 0 to 2 pi, L 1 upon pi, 0 to 2 pi. So what is the expression? And this expression also will be changed. So L will be replaced by pi. So if L will be replaced by pi here, so n pi upon pi, pi cancel, nx is left. L will be replaced by pi, so pi cancel, n into x is going to be left. So we'll see how to write that one. If we take L is equal to pi, then f of x is defined over the interval 0 to 2 pi. So then the formula will be reduced to a naught will become 1 upon L. Instead of L it will become pi, 0 to, instead of 2L it will be 2 pi, and remaining will be same, f of x into dx. Next, an formula will be 1 upon pi integration 0 to 2 pi f of x into cos of n pi upon L. L is nothing but pi, so pi cancel, will get nx here. So if you simplify and see, you will get this answer. And next, bn value will be 1 upon pi integration 0 to pi f of x into, it will be sine of n pi upon L, n pi cancel, sine nx into dx. We'll get these results. So based on this, our f of x will become, so f of x will become a naught by 2 plus summation n from 1 to infinity an into, so it is cos of n pi upon L. L value is pi, so it will become cos of nx plus n from 1 to infinity bn sine of n pi upon L. L value is pi, so it will become, it is also nx. So this is the result when L is pi. So if the given function f of x is of the interval 0 to 2 pi, this, so this expression is for what here, of the interval 0 to 2 pi if they have given. So this expression we are going to be right. So this where here a naught value is what here. So in this expression a naught value will be 1 upon pi 0 to 2 pi f of x dx. An value is 1 upon pi 0 to 2 pi f of x cos nx into dx, and bn value will be 1 upon pi 0 to 2 pi f of x sin nx into dx. So this we are going to be remembered here. So this case we have taken when L is equal to pi. So next case we'll see here. Now we'll see case number 2. Suppose c is equal to L. Before case number 1 we have taken c is equal to 0. Then we will have after that we have taken L is equal to pi. Now I am taking what here, c is equal to, when if it is case number 2, suppose c is equal to L, then f of x is defined over the interval minus L to plus L. So because we have the interval what here actually, it is c comma c plus 2L. So at that time, so this will become what here, in the interval minus L to plus L. Then the formula 1, 2 and 3 reduces to what here, that is the formula for a naught will reduce to what here, a naught result will be 1 upon L, that is the formula is what here, just see once again, I will glance it. So it is what here, we are going to replace c by L. sorry, C by, please just correct it here one. So replace C is equal to what here? Minus L. When if your C is replaced by minus L, the results of 1, 2, 3 will become what here? Uh, if you replace here C by what here? Minus L. So minus L plus 2L will become what here? L. So it will become minus L2 plus L. So the resultant will be, so if you replace C by minus L, so this result will become what here? 1 upon L, as it is. We are replacing C here. So C will be what here? Minus L. So minus L plus 2L f of x dx, which is nothing but 1 upon L minus L2 minus L plus 2L will become what here? L f of x dx. So a naught value is what here? 1 upon L integration minus L2 plus L f of x dx. Similarly, I want to write the result for an also. So an will become what here? 1 upon L integration, I will take directly, minus L2 plus L f of x into cos of n pi upon L dx into dx, and the bn value will be, 1 upon L integration minus L2 plus L f of x into sine of n pi L x into dx. So these are the results we need to remember when the value of C will be what here? Minus L. So anyhow I will give one more table to remember, but how it is getting the formulas we'll see here one by one. So now in this case number 2, when L is equal to C is equal to minus L, so then I will replace L is equal to pi. What happens, we'll see. So we have taken C is equal to minus L. If L is pi, then f of x will be defined in the interval minus pi to plus pi, because minus L to plus L will become what here? Minus pi to plus pi. Then a naught will become 1 upon L will become what here? Pi integration minus pi to plus pi f of x dx. First formula. An will become 1 upon pi integration minus pi to plus pi f of x into cos of n pi upon pi. Pi cancel, will get nx into dx, and bn will become 1 upon pi integration minus pi to plus pi f of x into sine of nx dx. So these are the results for the interval minus pi to plus pi, and previously we have seen the result what here. So this result is for what here? 0 to 2 pi interval, and if you see this result, this is nothing but for what here? Minus L to plus L. So these results I will club it, and once again I will show you how the results for the period 0 to 2 pi, what is the result? 0 to L, what is the result? Minus pi to plus pi, what is the result? And minus L to plus L, what is the results? We'll see once again in the form of table. So based on this minus pi to plus pi, we'll get final a function f of x will become f of x is equal to a naught by 2 plus summation n from 1 to infinity an into cos of nx plus summation n from 1 to infinity bn into sine of nx. So this is the final Fourier series where a naught value, b naught value, n value and bn value we have here. So in this way we need to describe the Fourier series. So Fourier series here we have seen in two kinds. One is of period 2L and another is period 2 pi. In period 2L we have 0 to 2L and minus L to plus L, two cases. And if you come to the interval 2 pi period, so there we have 0 to 2 pi and minus pi to plus pi. So these are the Fourier series where we are going to simplify. So we'll see the more detail in the next lecture.